The density of a cubic crystal may be estimated from the dimensions of its unit cell and the number of atoms of each element present per unit cell. So here we are going to see how to calculate the crystal density from unit cell dimensions. Let the edge length of a unit cell be equal to A picometer. As you know, 1 picometer is equal to 10 raised to minus 12 meters. Therefore, A picometer is equal to A into 10 raised to minus 12 meters. Or A into 10 raised to 12 into 100 centimeters. It can be simplified as A into 10 raised to minus 10 centimeters. Now, the density of the unit cell is equal to mass of the unit cell divided by volume of the unit cell. Since the edge length is A picometer, the volume of the unit cell should be equal to A cube. Here we have already converted A picometer into A centimeters, that is A into 10 raised to minus 10 centimeter. Therefore, volume of the unit cell is equal to A into 10 raised to minus 10 centimeter the whole cube. That is A cube into 10 raised to minus 30 centimeter cube. Now let's see about the mass of the unit cell. Mass of the unit cell is equal to number of atoms in the unit cell into mass of each atom present in the unit cell. The number of atoms in the unit cell is given by the symbol N. Mass of each of the atom in the unit cell can be calculated by atomic mass in grams divided by Avogadro number. Let's represent the atomic mass with capital letter M and Avogadro number by capital N. So the mass of the unit cell is equal to Nm divided by N. Now let's substitute these values of mass of the unit cell and volume of the unit cell in this equation, density of the unit cell. So density of the unit cell is equal to mass of the unit cell, that is Nm by N, divided by volume of the unit cell, A cube into 10 raised to minus 30 centimeter cube. Mass of the unit cell is in grams. Therefore, density is equal to Nm divided by 10 raised to minus 30 N A cube grams per centimeter cube. For a simple cubic lattice, you know the number of atoms per unit cell is equal to 1. For a body-centered cubic lattice, we know N will have a value of 2. For a face-centered cubic lattice, the number of atoms per unit cell is equal to 4. Please note that we have substituted the value of A in picometer and have obtained the density in grams per cc. So, when you are solving problems, please note that if you are substituting the value of edge length, that is A, in picometer, no conversion is needed. You will get density directly in grams per cc if you are using this equation. The density of the substance is the same as the density of the unit cell. If density of an element is known, you can calculate atomic mass, Avogadro number, edge length, or even number of atoms in a unit cell if all the other quantities are known. Now let's solve a problem. The edge length of a cubic silver crystal is 405 picometer. Its density is 10.8 grams per cc. Calculate the number of atoms per unit cell and comment on the type of cubic lattice it has. Atomic mass of silver is given as 107.9. We know the density of the unit cell is given by the equation D is equal to Nm divided by Na cube 10 raised to minus 30 grams per centimeter cube. And we also know that if the edge length is substituted in picometers, we will get the density directly in grams per centimeter cube. So let's write down the data given first. The edge length, that is A, is given as 405 picometer. Density of the unit cell is 10.8 grams per cc. You are required to calculate the number of atoms per unit cell. That is, you have to find out the value of small n. And you are also required to comment on the type of the cubic lattice it has. That is, whether it is a simple cubic lattice or an FCC lattice or a BCC lattice and so on. One more thing is given. The atomic mass of silver is 107.9. And you already know the value of Avogadro number 6.023 into 10 raised to minus 23. So from this equation, you have to calculate n, where the values of D, M, N, A all are known. No conversion of units is required here. You can directly substitute the values and find out the answer. If you try, you will get the answer as 4.004. That is, the value of n, number of atoms per unit cell, is 4.004. That is, it is equal to 4. And if n is equal to 4, it should be having a face-centered cubic lattice.